Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. So, in this video, we will continue to do some more questions related to speed time graphs, but these questions will be a bit advanced compared to what we have seen so far. Okay, so let us get started. Question number 10 is the diagram shows the speed time graph for 100 seconds of the journey of a car. Okay, so you have a 100 seconds journey and of a motorbike. Find the deceleration of the car between 60 and 100 seconds. So from this point, that is 60 seconds, and to this point, that is 100 seconds. So we need to calculate the deceleration. So we know that the acceleration is the same as the gradient of speed time graph. So if we can work out the gradient of this line, that will be equivalent to acceleration. So first of all, I'm going to write down the coordinates. We have 60 comma 18, and we have 100 comma 6. So a is equal to gradient, which is y2 minus y1, that would be 6 minus 18, divided by x2 minus x1, and that would be 100 minus 60. Okay, so 6 minus 18, that would be minus 12 upon 40. So let me work that out. So minus 20 divided by 40, that gives us minus 0.3. So this is the acceleration, but the question is asking for deceleration. So therefore, deceleration is equal to 0.3 meters per second square. Okay. Part B, calculate how much further the car traveled than the motorbike during the 100 seconds. Okay, how much further the car traveled than the motorbike during the 100 seconds. So now in this question, because we have two vehicles being compared, right? We have a car and we have a motorbike. So first we are going to work out that how much distance was traveled by the car, then we will work out how much distance was traveled by the motorbike, and then we will see that how much difference is there. So that would give us then how much further the car has traveled than the motorbike. Okay, so first of all, I'm going to write down that distance traveled in a speed time graph is equal to area under the graph. Okay, so now distance traveled by motorbike is equal to, so let's see. Now this is the motorbike. Okay, and we can see that the area under the graph of motorbike is a rectangle. Okay, so if you look over here, this is a rectangle, right? So now if I can work out the area of this rectangle, that would give me the distance traveled by the motorbike. So that would be length into width, which will be 100 multiplied by 12. So length into width, which is 100 times 12, that gives us 1200 meters. Okay, now distance traveled by the car. Okay, now the distance traveled by the car, if we look over here, let me erase this part. So you can see that we have, if I draw a straight line over here, so we can divide this shape into two known figures. One of them will be a rectangle, okay, this one, and the second will be a trapezium, which is this one. So you can ignore this line on motorbike, okay, and you can just count these two figures. So here we can say distance traveled by the car is equal to length into width plus half into sum of parallel sides multiplied by height. This is the area of trapezium. So length times width, that would be 100 multiplied by 6 plus half times. For trapezium, the first length is 70, okay, which is this one, and the second one is 100, which is this one. So 100 plus 70, and the difference between 18 and 6, that would be your height, which is 12. So we have 70 plus 100 multiplied by 18 minus 6. So this becomes 600. Half into 170 into 12. So 12 and 2, that would give us 6. So 170 times 6, that gives us 1020, which would be equal to, just a minute. Sorry, this one is 60. Okay, this length is 60. Let me quickly fix that. So this should be 60 plus 100. Okay, that would be 160. So that we have 80 multiplied by 12. So this is 960. And when I add them, that gives us 1560 meters. Okay. So now what we need to work out how much further the car traveled. So we can say that the extra distance traveled by the car is equal to 1560 minus 1200, and that would be 360. Okay, 360 meters. So this is how much further the car has traveled than the motorbike. Okay, so that is the end of question number 10. Now let us move to question number 11. The diagram shows the speed time graph for part of a journey for two people, a runner and a walker. Okay, so this is a walker, okay, who is traveling at a constant speed of 1.2 meters per second for 19 seconds. As for the runner, first of all, there is an increase in speed at a constant acceleration. Okay. After that, the speed becomes constant at 3 meters per second, and then and then he decelerates, okay, until it reaches a speed of 1.2. Calculate the acceleration of the runner for the first 3 seconds. Okay. So for the first 3 seconds, so these are our points. Okay, so let me write them down. So we have 0, 1.2, and we have 3, 3. So the acceleration will be equal to 3.0 minus 1.2 divided by 3 minus 0. So that would be 1.8 over 3, which gives us 0.6 meters per second square. Part B, calculate the total distance traveled by the runner in the 19 seconds. So we are interested in finding the distance traveled by the runner. So that means the whole area under this graph, everything. Okay, so again, it has already been divided for us. If you can see that with this dashed line, we can see that we have a rectangle, which is this area, and then we have a trapezium, which is this area. So together that will give us the total distance traveled by the runner. Okay, so distance traveled equals area under the graph. So distance traveled will be the formula for this rectangle, which is length into width plus half into sum of parallel sides multiply by the perpendicular height. Okay, so length will be 19 and the height of this rectangle is 1.2. So 19 times 1.2, that's the first one, plus half into. Now, as for trapezium, we can see the first one is going to be 19. Okay, plus. As for the second one, this would be difference between 15 and 3. So 15 minus 3, that would be 12. So 15 minus 3, okay, which we will work out as 12. And then later on, what is the height? That is this difference, right? The height between the parallel sides. So that would be 3 minus 1.2. That would be the height of trapezium, this one. So let us work this out. 19 times 1.2 is 22.8 plus half times. Now 19 plus 12, that would be 31, and 3 minus 1.2, that is 1.8. So the total would be 50.7. Okay, so the distance traveled by the runner in 19 seconds is 50.7 meters. All right, part C. The runner and the walker are traveling in the same direction along the same path. When t is equal to 0, the runner is 10 meters behind the walker. Find how far the runner is ahead of the walker when t is equal to 19. Okay, so in order to better visualize the situation, it is a good idea to draw a quick diagram. Okay, let me just draw one more time. Okay, so suppose that at this point t is equal to 0, and at this point t is equal to 19. Okay, now at t equals to 0, it says that the runner is 10 meters behind the walker. So if let's say that the runner is over here, the walker is 10 meters ahead, right? If the runner is 10 meters behind the walker, that actually means the walker is 10 meters ahead, right? So let's say that the walker is over here. Why I'm writing 1? Because this is the initial position, the starting position. So basically this is 10 meters. Okay, that is what we understood from the question. And then it says find how far the runner is ahead of the walker when t equals to 19. Okay, another thing that we need, okay, just one more thing. Find how far the runner is ahead of the walker when t equals to 19. So basically he's saying that after 19 seconds the runner is ahead. Okay, the runner is going to be, let's say, somewhere over here, while the walker is going to be somewhere over here. So this is the position. Okay, and we need to find that, okay, what is the difference in their distances. So both of these are at t equals to 19. All right, now another thing that we worked out just in the previous part is that in 19 seconds how much distance was traveled by the runner. So that means that from this green point to this green point, that is a total of 50.7 meters. Okay, now we need to work out. So from over here there's only one missing information, and that is how much distance was covered by the walker. So this is the only thing that we need to find out first, and then we can work this one out. Okay, so let me calculate that how much distance was traveled by the walker. Distance traveled by the walker is equal to now the distance traveled by the walker is just the area of this rectangle, right? So that would be 19 multiplied by 1.2. So 19 into 1.2 was 22.8, right? We already worked this part out. So that is 22.8 meters. So that means this is 22.8 meters. Now look closely. You know that from this point to this point, this is 50.7 meters. From this 50.7 meters, if I can subtract 22.8 and I can subtract 10 meters, I would be able to get this answer. Okay, so here we are going to write that again, I can use the word extra distance is equal to 50. No, let me just write one more thing. Distance traveled by the runner is equal to 50.7 meters. So therefore, extra distance equals 50.7 minus 10 minus 22.8. So 50.7 minus 10 minus 22.8, that gives us 17.9 meters. Okay, so that will be your final answer. And this 17.9 meters, this is the difference between the walker and the runners when they end at 19 seconds. Okay, so let me just quickly go through this one more time. The question says that the runner and walker are traveling in the same direction along the same path. Okay, so you have one single road and they are running. You have one single track and they are running on the same track. Okay, find sorry, when t is equal to 0, the runner is 10 meters behind the walker. If the runner is 10 meters behind the walker, so you can see there's a difference of 10 meters. Runner is 10 meters behind the walker. So in other words, walker is 10 meters ahead of the runner. Okay, find how far the runner is ahead of the walker when t equals to 19. So the question tells you that by the end of 19 seconds, it is the runner who will be ahead than the walker. Okay, so you need to find out that by how much distance will he be ahead. Okay, and that is how we have worked out. First we worked out that okay, the distance traveled by the walker will be 22.8, so that is between w1 and w2. Then we know the distance traveled by the runner 50.7, that is between r1 and r2. Okay, and since you already know that this is 10 meters, you can subtract 10 and 22.8 from 50.7 and you can get the answer to this question. Okay, so this one was a bit tricky question. Okay, all right, let's move to the last question. The graph shows information about the journey of a train between two stations. Work out the acceleration of the train during the first 4 minutes of this journey. Give your answer in kilometer per hour square. Okay. So because the time is in minutes and the speed required, sorry, the acceleration required contains hour. So I'm going to change the time first. So time is equal to 4 divided by 60. Okay. So 4 divided by 60, that gives us 1 upon 15. Because if I write down in fraction, sorry, if I write down in decimals, so that would give me a long answer. Okay, so instead of that, I'm just gonna leave it in fraction. So we have 1 upon 15 hours. Now to work out the acceleration, I can look at the coordinates. So we have 0 and 0. We'll assume that this is 0, and then the speed is 126. The time is 4 minutes, which we have already converted into hours. So I'm going to say 0 0, and then we have 1 upon 15 hours, comma 126. So now I can work out the acceleration, which will be 126 minus 0 divided by 1 upon 15 minus 0. So 126 divided by 1 upon 50. That would give us 1890 kilometer per hour square. Part 2. Calculate the distance in kilometers between the two stations. Okay. So first of all, we know that distance traveled is equal to area under the graph. All right. So that would be the area of this trapezium. So let's see. This would be half into now sum of parallel sides. So from here to here, this is 15 minutes. Okay. So this would be 55 minutes. 55 divided by 60, because remember, you have to be unit consistent. We cannot just take 55 minutes while while our speed was in kilometers per hour. Okay, so this time must also be converted to hour. Plus here it took how much time? 48 minus 4, right? So we have 48 minus 4 divided by 60. All right, and then we multiply by the height of trapezium, which is 126 kilometer per hour. All right, so now this would be 1 upon 2 times 11 upon 12 plus, so we have 44 over 60, sorry, 40, here 44 divided by 60, which will be 11 upon 15. Okay, and we have 126. So when I work this out, I would get actually in this step I can also simplify them, right? I can say that 2 and 126, so this becomes 63. Okay, so now when I multiply that 63 times 11 upon 15 plus 11 upon 12, so that gives us 103.95 kilometers. So this is the exact answer. Okay, now if it feels a bit confusing, so what we can also do is we can say that the time, this one, and this one. So let's start with this one. So this is 55 minutes, right? We convert this 55 minutes into hours. So that becomes 11 upon 12 hour. The second time is 48 minutes minus 4 minutes, and then we divide that by 60. So that would be 11 upon 15 hours. Okay, which is this one. So this is your A and this is your B. So this is your A and this is your B. Okay, and then you just substitute this into the formula, half into A plus B into height. Okay, the area of trapezium. All right, now part B is show that 126 kilometer per hour is the same speed as 35 meters per second. So we have to convert the units. So in my previous videos I've taught you the method that you could easily use. So this is 126 kilometer, and then I'm going to write hour over here. Just extend this, and now I need to convert kilometers to meters. So that means I have to get rid of kilometers, and that can happen if kilometer is in the denominator. Okay, so now this kilometer cancels with this kilometer. Now this 1 kilometer is equivalent to 1000 meters. Why meters? Because that is the required unit. All right, now we need to convert hour into seconds. So because the hour is written in the denominator, In order to cancel this out, we have to write hour in the numerator. So we have 1 hour over here, and that is equivalent to 3600 seconds. So now you can cancel the hour and hour. So that's the conversion is done. Now we just need to simplify it. So we have 126 multiplied by 1000 multiplied by 1 divided by 1 times 1 times 3600. So now you can simplify. The zeros can cancel two of these, right? So now you have 1260 divided by 36, and that gives us exactly 35 meters per second. Okay. Now, part two is the train has a total length of 220 meters. Okay, this is the length of the train. At 9:30, the train crossed a bridge of length 1400 meters. Calculate the time in seconds that the train took to completely cross the bridge. This is a very important part of the statement, okay? Now, usually what would students do is that let me draw this, okay? Let me make a quick sketch of the situation. So suppose that this is my track and this is your train. Now, usually what happens if you are comparing your distance, okay, so let's say this is the length of the track, which is 1400 meters. Usually what happens is that if you're comparing the length of the distance, so if you're starting to compare from the first wheel or from the front of the train, then you also end at the front of the train, isn't it? You end it like this. So you're taking the distance from the front part of the train and to the front part of the train, the front to front, or you compare from back to back. Okay, but if you measure it in this manner, the problem is that you do not you do not interpret the question in the way it is asked, right? It says that how much time it takes to completely cross the bridge. When you're measuring it, the train has not completely crossed the bridge, isn't it? So that means that what we have to do is we have to draw it further like this. You have to make the train cross the bridge. So after it has crossed the bridge, that would be the position of the train, right? That means that the train has actually traveled an additional 220 meters, which is the length of the train itself. So the total distance which is traveled by the train is not only 1400 meters, it is actually 1400 meters, which is the length of the bridge, plus 220 meters. Because I just showed you what was the initial position. The initial position would have, sorry, the position after crossing the bridge would have been over here, right? But because it asked us to completely cross the bridge, it has to travel another 220 meters. Okay, so I hope that you understood that. So that means if I now apply the formula, time is equal to distance over speed. The distance is going to be 1400 plus 220, and the speed is going to be it was 35, right? Because it says that at 9:30, and at 9:30 is it is between the it is in this part of the graph where the train is traveling at 126 kilometer per hour or 35 meters per second. So the train is in this region. Okay, now I'm going to write here 35 because we need to calculate the time in seconds. The distance is given in meters, so therefore the speed that I'm going to use will be 35 meters per second. All right, So now when I work this out, 1400 plus 220 divided by 35, that gives us 46.3 seconds to 3SF. Okay, so that is the end of this particular topic where we dealt with speed time graphs. Okay, so I hope that you understood this topic clearly, and you can see that we spent a great deal of time in covering this topic because this is a very common topic that usually pops up in either paper 2 or paper 4. Okay, so make sure that you practice these questions. We have done quite a variety of questions, so make sure that you understand them clearly and then you also practice these questions by yourself. So I'll see you in the next video then. Take care. Assalamu alaikum.